So this is the third property for angle properties of circles. So in this topic, there are some properties that give rise to 90 degree. So this is one of the more common one. So this property is called angles in a semicircle. So to look out for this property, you will need to look for diameter. So the question will definitely tell you about diameter, but the characteristic of a diameter is it is a chord. So a diameter is a chord, except that it passes through the center. So there will be some lines that look like diameter, but as long as it doesn't pass through center, it will not be classified as a diameter. So you have to look out for that. So the 90 degree is directly opposite the diameter. The 90 degree will be directly opposite the diameter, and it should be sitting on the circumference. So a lot of time, this property will be used to explain certain situation. So if there is, so later on you will see some question where they will explore this property in the explanation way rather than in a calculation way. So it can also be on the other side of the diameter. So it can be very slanted, doesn't matter, as long as the 90 degree is directly opposite the diameter. And it has to be sitting on the circumference. The next one will be quite a popular property, which what we call angles in the same segment. So for this, to look out for this property, we will look for a chord. We will look for a chord. So from the chord, you can make an angle that is directly opposite the chord. So this angle is sitting on the circumference. So from this chord, you can create any angle on the circumference. So because it's any angle on the circumference, you can also create it this way. That means any one of them. So all the angles on the circumference will be facing that same chord. So if you take a look from the same chord, so all these they are sitting on the circumference, they are facing the same chord. So this is what we call angles in the same segment. So this will be a very popular one. But for some question, if the chord is not presented to you, so for example, like this, sometimes it may not be presented to you. They will just show you question like this. Sorry, it's not meant to be like this. So maybe they will just give something like this. So maybe they just give something like this and you don't see any chord, so you could have added in a dotted line. So if you add in a dotted line here, this angle is facing the same chord. So these two angles fulfill the angles in the same segment property. So sometimes it's okay that you put in a dotted line to represent the chord that you don't see, so that you can relate to this property. Another extension to this property will be something like this. So sometimes they will have given you same length chord. So this chord and this chord are exactly the same length. So when they are exactly the same length, So if I do something like this, not very nice. Okay, so if I do something like this, it also fulfill this property, but it doesn't look. So this is opposite this chord. So for the other one, right, which is same length, so this angle is facing this chord, but both angles are the same. So both angles are the same. It is also angle in the same segment. Okay, so they are not facing the same chord, but the chord that they are facing are same length. So that also fulfill this property. So this one sometimes is some student never realize that it's actually under angles in the same segment, and it kind of affect for a full question.